Effects of parameter k on y equals sine k theta. We shall now investigate the effect of parameter k on the sine function y equals sine k theta. Consider the sine function y equals a sine k theta plus q, where a equals 1 and q equals 0, and k equals 1. It becomes the sine function y equals sine theta, which we saw earlier. Consider the sine function where k equals 2. The function becomes y equals sine 2 theta. We can calculate the y values of this function and plot the graph on the same set of axes. Observe the amplitude of the graph of y equals sine 2 theta is the same as that of the graph of y equals sine theta, hence the amplitude of the graph has not changed. However, the period of the function has changed. Period of the function y equals sine 2 theta is 180 degrees, which is half the period of the function y equals sine theta. Hence we can say that changing the parameter k affects the period of the function. Now, let us consider an example when k is less than 1, say 1 over 2. The function becomes y equals sine theta over 2. We can calculate the y values and plot the graph on the same set of axes. Again, there is no change in the amplitude. However, the period of the function has changed. Observe that the period of the function y equals sine theta over 2 has in fact doubled when compared to the period of the function y equals sine theta. Now let us consider a couple of examples where k is less than 0. Again, amplitude does not change. However, when k is negative 2, the period has reduced by half. Let us summarize our findings on the effect of parameter k on the sine function. For k greater than 1, the period of the sine function decreases. For k greater than 0 but less than 1, the period of the sine function increases. For k greater than negative 1 but less than 0, the graph is reflected about the y-axis and the period of the function increases. For k less than negative 1, the graph is reflected about the y-axis and the period of the function decreases. Note that we can also calculate the period of the function algebraically. We simply divide the period of the basic sine function by the magnitude of k, that is, ignoring the sign.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.